Hi, Jeff Disher here again. Sorry, I've been out for a few months. I've been pretty busy with a lot of things lately, but today I'm going to get started on a topic that I've been wanting to talk about for quite some time, which I'm going to just call Federated Architecture. So, okay, what is this? Well, a federated architecture describes interoperability between decentralized autonomous systems. So, this is as opposed to centralized monolithic systems, like when everyone connects to the same big mainframe or something like that. The federated system is more like the internet, where you have a bunch of individual components that you can talk to, and but individually they all kind of operate as their own thing. Without the rest of the network, they still work. A good example of this is email. This is a system where, yeah, you have a bunch of little systems that you're trying to interoperate with. You're going to send messages between them. Users on the different systems, they can be on the same system or on different ones. It doesn't make a difference. Another common one that's a good example is XMPP, or what's often called Jabber. People use it mainly for instant messaging, but in fact you might be using it without knowing it if you use something like Gmail. But it also can be used for other things. And OpenID is one that people probably aren't familiar with, but it's used to provide to solve an identity problem of who you are on a distributed system, like the internet. So how does this work in email? Well, email solves the problem of distributed messaging. This is one we're probably all very familiar with because we've probably been using it since we first connected to the internet, whenever that was. So basically it just means users on different servers can talk across the server boundaries. You don't all have to be using Hotmail to communicate with Hotmail people. You don't all have to be using Gmail. It doesn't matter where you are. You can send messages between the servers. It just works. Great example, right? User at example1.com and user at example2.com are on different servers, but they can still interoperate as though they were on the same. It doesn't matter. So this is kind of interesting. Part of the reason why this has lasted for so long is there's no central authority. You can even manage your own email server if you want. A lot of people do. A lot of people have random web hosting they get from some company on the internet, get managed email for them. It's really great, and that's part of why it's lasted so long, because it wasn't up to one company to control and shepherd it and keep it and make sure that it remained financially viable, but also open and accessible enough that people wanted to use it. There's problems with email, of course. There's no quality of service. You can have lost messages where you send a message and it just never arrives, or it arrives several hours later. That's kind of how it was built because of the realities of the internet when it was being deployed. Also, there's no authentication. Sure, there's a from address on the email, but the from address doesn't tell you who it's from. When you send an email, you put the from address on it yourself. So you could be Bob and you send an email saying it's from Alice, and the receiver can't tell the difference. There's ways they can sort of tell the difference. There's solutions to this problem using certain kinds of digital signatures and trust networks that way, and those work. It's just they're not used by everyone, so they're not a general problem or general solution to the problem. This leads to spam problems. In terms of XMPP or Jabber, this is distributed presence is really what it comes down to, which is as I said before, it's used for instant messaging, which is basically just kind of like a lightweight email plus the ability to tell is the user online or not. The online or not is what we refer to as presence in a more general sense. So this is used by all sorts of different instant messaging protocols. Not all of them. A lot of the older ones like ICQ and MSN and AOL do not use this. They're centralized or walled garden systems. Newer ones like Gmail, though, is an example of one which is actually a Jabber one. So you can be on different Jabber servers and everyone interoperates as though they were on the same. An example, again, same users as before, across different servers, they can talk to each other using Jabber, using a chatting system as though they were on the same. So again, there's no central authority. Anyone can run their own. In fact, I run my own here at home. There's quality of service is actually pretty good in Jabber. Usually a failed delivery can be detected by the server itself. So if it doesn't manage to send a message to somebody in a certain time frame, it'll actually be able to tell you they didn't receive this, which is actually very helpful. Because sometimes that happens for good reasons, and you knowing that it didn't reach them is really important. Authentication is managed by each user. Whoever's managing a server can try and restrict that, or can automatically whitelist a bunch of people or other servers. But generally speaking, this is managed by the individual themselves. Someone wants to contact you, you authorize them, and now they can see your presence. So that works fairly well. OpenID, now, this is one that people are probably not very familiar with. It's used a lot in various technical circles these days. but it never really made mainstream acceptance within a lot of pre-established sites from before the era where it became popular. It's used for distributed identity. This means that instead of you having a username and password on 10 different sites you use, you just have a username and password or something else at what was called your identity provider. And then you would go to all these other sites and just say, I am this identity, which would just be a URL. Looks like a web address. In fact, it often is. And that would be able to authenticate you using what's called a distributed trust mechanism over the internet. So you could have one identity that would show up everywhere, and it would just be you. So this was originally deployed on livejournal.com. It's written by a guy named Brad Fitzpatrick, who's the original founder of LiveJournal. But now countless other sites use this. So it's pretty common. You can see it on Slashdot, a bunch of other sites. These days, it shows up pretty well everywhere. What it comes down to, as I said, it's just a URL. You get something that just looks like any other address you're going to pop into a web browser. You just copy and paste it into this, and that's how you log in everywhere else, instead of remembering a username and password. The only real concern that OpenID has, first of all it does is solve the identity problem. It doesn't do much else, which is great, because that's a very generic problem. That's a problem that we've had on the internet since people first started using it, was how do you actually manage multiple identities across multiple sites. So this was great for that. It also, in terms of a security concern, there's something called phishing, the trying to get someone to accidentally or fool someone into giving you authentication data. People were doing that for a while using OpenID, but generally these days that doesn't happen because there's been some rules of thumb that have been picked up on OpenID servers to make this really hard to accomplish. Basically it just means you'd put in an OpenID URL, and the authentication, what it would do is redirect you to a fake site that looked like your real site and asked you for your username and password. Usually what they do now is they just say you can't log in if you're trying to authenticate using the ID, because that could be someone fooling you into doing it. That wasn't the problem with the protocol though, that's just a problem with how people use things and what they're used to in terms of when to pop in usernames and passwords. So this is a pretty good system though. So this stuff is all in opposition to the kind of the other way around, right? What we call a walled garden. This is basically the opposite. Now, it's not strictly an opposite. You can have somewhere in between, but realistically, it's the opposite from a philosophical point of view, if nothing else. So, examples of this are MSN for instant messaging. It's a walled garden. Facebook or G+ for messaging or social networking and data management. They're walled gardens. They're based on centralized authority and control. So, one company controls what actually goes on, what services are allowed, how you can use the system, and often even who owns the data. In most of these cases, companies like Facebook or Google, they will own, in some cases, some of the data. I'm not up to date in the most recent agreements. But you want to hear a recent example of that? Look at the Instagram fiasco. These things provide limited interoperability and data mobility. Usually, they're based around a business model that kind of requires that you be stuck inside them. They don't want to make their systems interoperable because then they're looking for a sort of, it's an internet equivalent of what back ages ago we used to refer to as vendor lock-in. So it's important that they make you need to, it's important that you need them. So they want to make sure that you continue to need them. So they tend not to be very interoperable. Similarly, this leads to data mobility concerns. They don't really want to help you get your data out of them. They kind of require it being there. A good example of someone who doesn't do that but is a walled garden is Google+. They actually have a very good data mobility system right now. But because they control the whole system, what promise do you have that that's going to continue being the case? So this leads to the big concern of who owns your content. You put a picture somewhere, and that company decides to sell it to someone for marketing material. Did they violate your rights? Probably not. Most of these services have clauses in their licensing agreements saying that once you put data there, they own it. Part of the reason they have to do that is because they're serving it. If they were serving data that you owned, that would be kind of a more complicated legal case, but also it's how their business model works. They actually own that content because they're going to do something to monetize it. Either they're going to look at it to get information that they can use to figure out how to advertise to you, or they're going to actually sell it directly to somebody else. And these things always have longevity concerns. a good example of this, email, like I mentioned before, has been around forever. It's in largely its current form, it's been there for 20 to 30 years without really any change, because no one controlled it. Everyone agreed that they were just going to use it because it worked. It's got its problems, but it's never big enough problems for us to get rid of it. It actually works, and any of the solutions that have come up have been these short-lived, flash-in-the-pan ideas of, oh, if everyone does what I tell them to do, the problem will go away. It's like, well, that's great, but how much longer are we going to want to do that? Right? What happens if you put all your data inside one of these companies, inside one of these services provided by a company like this, and then they change their licensing agreement such that you can't access it? Or what happens if they're bought out by somebody else who wants to do something with it? Do you want to continue using these services given that you're giving them complete control over everything? And also, what happens when something more interesting shows up the following year and everyone starts using that? Well, now you have to move all your data because there's no interconnectivity, there's no interoperability between the systems. Why would you continue using this? You're now not wanting to use it, you're being forced to use it. Those things are things that people try to move away from over time. So that's one of the concerns with people using things like this is, at some point you're going to change your mind and use something else. So anyway, I'm hoping this has been kind of useful in terms of explaining the difference between a federated architecture and a closed system, centralized and decentralized ideas, how those things work on the open internet and in the modern age too. I've been very busy the past few months. I've actually been working on a new startup, which will actually solve some of these problems. So I'm hoping to start talking about that a bit more in the coming kind of month or two, probably using this account for that information. So stay tuned.